Hi everyone, I am Zhou Yuan, and this is lab 4, oscillation. In this lab, we need to compare the motion of the spring in the video with our predicted model using tracker. In the end, we found that the two models are similar, since the total energy remains unchanged. First, let's take a look at our model. And we are going to use Newton's second law, which states that F is equal to delta P over delta T. And we are also going to use a new concept called energy principle. That states that delta E is equal to the work of the surroundings plus the energy emitted. We are also going to use two formulas. The first one is the gravitational potential energy. This is equal to mgh, which m is equal to m is the mass, and g is the gravity, and h is the height. We are also using spring potential energy. This is equal to half of the spring constant times the delta the displacement squared. And we assume that the predicted model would match the observed result. Here's our experiment. So we can take a look at the graph on the left. This is a graph that consists of four components. The first one is delta K, which is the delta kinetic energy. This is in blue, and the red one is a delta gravitational potential energy. The green one is a delta spring potential energy, and the orange one is the total change in energy. And we can see that it remains constant, which is 0. And in this experiment, we used the following coding. So first, we find the interaction constant, spring, and energies. We found out that the L is equal to ball's position minus the spring's position, which is the displacement. And also we are going to find the following, like the kinetic energy. We're going to apply the formula directly, and then the gravitational potential energy and the spring potential energy, they are all according to the formula I mentioned before. And then we are going to talk about the system properties, initial conditions, and data. So in this case, our ball is 0.402 kilograms, and then I plug in the ball's position according to the tracker, and in the end, we're going to calculate the energy changes again, and at last we're going to find out the apply the momentum principle, which is Newton's second law, to find out the final result. So what does it mean? So we can find out that the energy principle is satisfied, since the delta E, which is the orange line, is always 0. And also we can predict that the period of the x component is 1.7 seconds, while the period for y component is 1.6 seconds. So the difference, it is probably because of there's a drag force. So in conclusion, our model matches our predicted model matches the observed results in the video. Thank you.